In this video, I will explain how to use Huffman coding. So Huffman coding is a compression technique used to reduce the number of bits needed to send a message without any loss of information. So let's check out an example of how to use Huffman coding. Let's say we want to send this message right here. Now in ASCII, each of these characters is represented by 8 bits. So if we wanted to send this message, there's a total of 9 characters in this message. So the total number of bits that we would need to actually send this message is 9 times 8. Which is 72 bits. So the idea with Huffman coding is let's see if we can send this same message using fewer than 72 bits. So the first step when we're using Huffman coding is we have to calculate the frequency of each character in the message. So let's go ahead and write all of the unique characters in this message. So we have A, B, C, and D. Now let's check out the frequency of each of these characters. So character A occurs 4 times in this message. Character B occurs once. Character C occurs 3 times, and character D occurs only once as well. Now what we're going to do is build something known as a Huffman tree. So that's where we write out each of these unique characters based on their frequency from least frequent to most frequent. So we can see that B and D both occur once, so we can start with either of those. It doesn't matter which one. Let's just say B. And we'll write a little 1 next to it to indicate its frequency is 1. Then we can write D, so moving to the right we'll write D. Then the next frequent character would be C, which has a frequency of 3, and lastly we have A, which has a frequency of 4. Now what we're going to do is join the 2 characters that have the smallest frequencies. So that would obviously be the B and the D. So if we join these 2, we have 1 plus 1, that's a frequency of 2. So we'll create a little node right here with a frequency of 2. Now we're just going to repeat the process and we'll say, okay, which 2 nodes can we join that would have the lowest frequency? Well, that would be this 2 and this 3, which would make a 5. So we'll join these 2. And this new node will have a frequency of 5. And now we can see there's only one other node to join, which is A. So we'll join A with this 5 right here. So that would have a frequency of 5 plus 4, which is 9. So now what we do is for each branch going to the left, we'll write a 1. And for each branch going to the right, we'll write a 0. So 1, 0, 1, 0. And now what we can do is we can represent each of these characters using only 1s and 0s. So the way that we do that is we start with the node at the very top, and we just work our way down to each character. So for the A, we can see that would be coded as a 0. So we'll write a 0 underneath it. For the C, that would be a 1 and a 0. So let's write 1, 0. To get to the D, we have to go 1, 1, 0. So we'll say 1, 1, 0. And to get to the B, we have to go 1, 1, 1 to get all the way down here to the B. So that would be 1, 1, 1. So now these are the binary numbers that we can use to represent A, B, C, and D. So let's go ahead and write them over here. So for A, we'll use a 0. For B, we'll use a 1, 1, 1. For C, we use 1, 0. And for D, we're going to use 1, 1, 0. So what we can do is we can use these binary values to send this message. So for example, a B, that would be represented as a 1, 1, 1. So let's write the message down here. So we have a 1, 1, 1. Then we have an A, which is represented by a 0, another A, another 0, another A, another 0, another A, another 0. Then we have 3 C's in a row, so those are represented by 1, 0. So we'll say 1, 0, 1, 0, 1, 0. And lastly, we have a D, which is represented by 1, 1, 0, 1, 1, 0. So this is how we would send the original message using Huffman coding. And there's a total of 16 bits right here. So let's say 16 bits. But when we send this message that has been Huffman coded, we also have to send a list of the characters that we used along with their corresponding binary, because otherwise we wouldn't know how to decode this message. So we would have to send these 4 characters. Remember in ASCII, each of these characters is represented by 8 bits. So that's a total of 4 times 8 bits. So that would be a total of 32 bits that we would also have to send. And we have to send these binary values to show which ones correspond with each of these characters. So there are a total of 9 binary values right here. So that's 9 more bits that we have to send. But even after accounting for the characters and their binary values, the total number of bits right here comes out to 57 bits. So we can see that's still significantly less than the original 72 bits that we would have had to use. So by using Huffman coding, we were able to send the same message without any loss of information, but we were able to do it using fewer bits. And the key idea with the Huffman coding technique of why it works is because when we build this Huffman tree, the characters that have the highest frequency have the fewest number of bits needed to send them. So we'll notice that character A, which had the highest frequency of 4, each time we send an A, we're only using 1 bit. And similarly, the character C, which has the next highest frequency, has the next fewest bits needed to send it. So because the more common characters require fewer bits to send them, that's really the core idea of why the Huffman coding technique is such a good compression technique.